We will be using in class 40 for our notes today. This is the fifth and final day of Standard 9. We are focusing on our third special parallelogram. So today is all about squares. We are going to take care of both algebra problems or numeric problems related to applying the properties of squares and also taking a look at what a coordinate proof would look like in order to prove that a quadrilateral is a square. So first and foremost, we are going to talk about the definition of a square. So a square is a parallelogram, like the others that we've been studying, but it is also a rhombus and a rectangle. And so as we think through the properties that are true for a square, really what it boils down to is that all of the properties of all of these other parallelograms that we have studied are true, which means we have a pretty extensive list of things that we can do when we're dealing with a square. Now, the good news is that when all of those properties combine together, it really restricts the options that we have for squares, because if all of those things are true at the same time, we have some very specific outcomes. So from the rhombus properties, we are going to have 4 congruent sides. And then from the rectangle properties, we are going to have 4 congruent, but that means that they are 90 degree, or another way of saying that is right, angles. We also know a lot of information about our diagonals. The diagonals are congruent. That was a rectangle fact. They also bisect each other. So they also have parallelogram properties, which is where that bisect each other comes from. Thinking about the rhombus properties again, the diagonals are going to be perpendicular. And those diagonals bisect the opposite angles. So we have all kinds of pieces of information that are going to be able to help us to solve problems when we're dealing with squares. All right, let's go ahead and see what we can come up with in terms of solving problems. Each of these problems is about square A, B, C, D. So we know we're going to be able to use all of the parallelogram, all of the rhombus, and all of the rectangle properties. This first problem seems to be giving us information about segments. So if we're thinking about segment AD, that would be this side at the bottom of that square. Segment DC is on the right side, 9 plus 4x. And if we're thinking about what's true, we just got done saying that there are 4 congruent sides when we're dealing with a square. So that means we're going to be able to take that 7x minus 24 and set it equal to 9 plus 4x. That is up there in reason number 1 at the top of the page. 4 congruent sides. If we subtract 4x to get all of those x's on the left side of the equation and add 24 to move all of the numerical values to the right side of the equation, we're going to end up dividing both sides by 3 to track down our value for x. The second request for this problem is that we think about what AB is equal to. Now, AB is a side that's empty, but remember, all of our sides are congruent, so it really does not matter which of these expressions we pick. We can take either one, and we can plug our x in, substitute that value, and that should give us the length of segment AB, as well as all of the other sides of that square as well. All right, let's take a look at example number 2 and see what that one seems to be about. More segments. So as we're looking at segment AE, that is going to be a portion of this diagonal, 8x plus or minus 3, between A and E. And then BD, this entire diagonal here, is equal to 58. All right, if we are looking for that information, it looks to me like we've got a whole diagonal and then a piece of a diagonal. If we were only allowed to use parallelogram or rhombus properties, we would be in trouble because there isn't anything true about this diagonal compared to that diagonal in those two shapes. But remember, we're also allowed to use rectangle properties. So if we combine what's listed in reason number 2 up above, that these diagonals are congruent, but they also bisect each other, that means that all 4 of these little segments are going to match. So if I took 2 of these, that would match up with segment BD. So 2 of those 8x minus 3's is going to be equal to 58. The other option would be that you divide that 58 in half. That would work as well. But I'm going to go ahead and continue on by thinking about how 2 of the small parts add up to be the whole thing. And we'll solve the equation by distributing and then adding 6 over to the other side. Looks like when we divide both sides by 16, x is going to turn out to be 4. And since they just asked me for x, that's all I need to worry about. So x is equal to 4. We will continue on to example 3 next, and it looks like angles are going to be the focus this time. And I see no information given to me, which is highly suspicious. So let's think about what we know about angles. If we were dealing with a parallelogram, we would be in serious trouble because we have no consistent measurements for angles in parallelograms. They can be all over the place. But if we think about our rhombus properties, since we're also allowed to use those, anytime we saw that we were dealing with a rhombus a couple of days ago, I said that my first go-to is to go ahead and label all of those inside angles as 90 degrees. That's related to the fact that these diagonals are perpendicular, so they form 4 right angles on the interior of that shape. So we can go ahead and label those using our rhombus properties. And then I think the key is going to be to remember from our rectangle properties that these triangles in here are isosceles. And so if we have a situation, let's take this bottom triangle for example, where we know that that top angle is 90 degrees. When we consider the fact that this is isosceles, we can travel across from those congruent sides and make our way to some congruent angles. And so what that tells us is that these 2 angles together have to be, number 1, the same as each other, but also have to add up to be 90 so that we get a sum of 180 degrees total. So we could do a quick little subtraction problem here where we get rid of that 90 degrees. And then remember that leftover 90 degrees is going to get split in half to make these 2 base angles congruent to each other. So that's one way of figuring out that these angles are 45 degrees. We could repeat that process over and over and over again in different triangles, but we would get the same result every single time. So that means that all of these angles around the corners are going to be 45 degrees. Now there is another way to think about that. That was using a rectangle property. So instead, let's consider the rhombus property that says that this diagonal bisects this angle. That tells us that these back-to-back angles match. But then we know from rectangle properties that this total is 90. So if that whole corner is 90 and it's bisected, it's divided in half, that's another way to explain why these angles are 45 degrees. So no matter how you think about it, when we end up combining the rectangle and rhombus properties together, we end up getting a situation where there is no variety in the angles for a square. Every single angle in a square is either a 90-degree angle if you're in the middle, or if you're looking at a whole corner, or a 45-degree angle if you're looking at the pieces that the corners are divided up into. All right, let's flip the page and see what else we have to take a look at today. All right, the second part of our lesson today is focused on the coordinate proof and what that looks like when we're dealing with squares. So as always, we are going to start by graphing our 4 points. A is at 0, 5, so that just means we're going up 5 to find point A. B is at 3, 6, so 3 to the right and then 6 up. C is at 4, 3, 4 to the right and 3 up. And then D is at 1, 2. So 1 to the right and 2 up. Taking a look a little bit lower on the page, they're naming the quadrilateral A, B, C, D. So I'm going to go ahead and connect those points in that order to make my quadrilateral. And then we are remembering that a square is a parallelogram that is also a rhombus and a rectangle. So the good news about that is that in order to show that something is a square, we're not going to have to learn anything new for our coordinate proofs. We're just going to need to combine the things that we've already been doing for our rhombus and for our rectangle. All right, first things first though, we need to make sure that we are going to prove that those vertices form a parallelogram. Because if it's not a parallelogram, it's not going to be a rhombus or a rectangle. So we won't do those tests until after we know that we're dealing with a parallelogram. Parallelograms mean that we're focused on slope. So whether you're using your slope formula or you're using the counting method to find your slope, our goal is going to be to focus in on opposite sides. I have AB listed first, followed by its opposite side, segment DC. So if we're looking at rise over run, we would have a +1 and a +3 for segment AB. +1 and +3 repeats for segment DC. So yes, those two segments, those two opposite sides are parallel. We're going to repeat that for the other two. I don't know if I can get that into the screen at the same time. That looks okay. So first up is segment AD. The rise would be down 3 and right 1. So that would be a -3 for the numerator and a +1 for the denominator. And then segment BC looks like the same thing, down 3 and right 1. So again, those are parallel, which means that we know now that segment AD is parallel to segment BC, and we do in fact have a parallelogram. All right, continuing on, if we're focused on the rhombus next, we're going to continue to look at slope. And remember that we need to show that those consecutive sides are opposite reciprocals in order to say that there is a right angle. If they're not opposite reciprocals, then there's no right angle. So if we look at, this is not testing for a rhombus, this is testing for a rectangle. The right angle is what tells us whether or not we have a rectangle. So if we're looking at opposite sides, we need to select 2. I'm going to pick these 2 right here. Let's compare segment AB with a slope of 1/3 to segment AD with a slope of -3 over 1. Those are opposite, one positive, one negative, and it looks like the numerator becomes the denominator and the denominator becomes the numerator. So these are opposite and reciprocal, which means yes, there's a right angle. And I'm going to make myself a mental note that that means that we do have rectangle characteristics, just like this information up here told me that we were dealing with parallelogram characteristics. So far, we know that our shape is a parallelogram, but it is also a rectangle. Now we'll go over to the rhombus characteristics. Remember that the rhombus needs to have consecutive sides congruent. So that's why we're switching over to our distance formula. We're focusing on those same consecutive sides, AB and AD. So you have your ordered pairs up at the top. I would suggest that you go ahead and label them as x1, y1, and x2, y2 for A and B. And then you won't be able to see those as I go through the plugging in process, but you can see them on your own paper. If I'm looking for x2 first in my formula, that's going to come from point B and is equal to 3. We're going to subtract x1 from point A, which is 0. Remember that subtraction gets squared later, and then we're going to add on to that y2, which is 6, minus y1, which is 5. Some quick simplifying inside those parentheses first. 3 minus 0 is 3. 6 minus 5 is 1. Squaring is up next, so we end up with 9 plus 1, which is root 10 as the length of AB. All right, we're going to repeat that now for AD, the consecutive side. So I'm going to keep my x1, y1 as A, but I'm going to replace my x2 and y2 with the ordered pairs from D. So now when I'm filling in that distance formula, x2 is going to be 1, minus x1 is still 0. Y2 from point D is 2, minus y1 is still 5 from point A. Doing some simplifying again inside those parentheses, 1 minus 0 is 1, 2 minus 5 is negative 3, 1 squared is 1, negative 3 squared is still positive 9, and so we still get the square root of 10 as the length of side AD. Because these match, we know that side AB is congruent to side AD, which means we are now in rhombus mode. So we got a yes for parallelogram from the opposite sides being parallel. We got a yes from rectangle for those opposite sides having consecutive sides having opposite reciprocal slopes, which forced a right angle to happen. And then we have consecutive sides again, this time being congruent, which gives us our rhombus indicator. So our final conclusion on this one is that quadrilateral ABCD is a square because it is a parallelogram and a rectangle and a rhombus. If any of these had been a no, then it would not have been a square, and on your test you would have decided what it was. We'll practice that in the coming days. All right, thanks for watching. We'll see you back in class.